Okay, good morning. So at this point we're looking at geometry. We're trying to wrap this section up. We also have started our trigonometry, but I said we're going to do geometry today, not so? I think. So let's try and get ahead of this here. Or catch up. Yes, somebody put it, there we go. I thought maybe they wanted it anymore. Okay, so at this point we are, where must I start? Where did we stop? We stopped at 10E, no. Must I start with J, is that correct? Okay. So in 10J we are told number 1, I'm still seeing you the written memo of this, no? As soon as I did. Okay. So we are told that angle A is x. Okay, so today will be the last lesson. Okay. So angle A is x, and angle B is 2x. Angle B is 2x. Calculate the size of angle ABC and D if ABC is D is a parallelogram. So for this to be a parallelogram, 4 things comes to mind. At this point, you should know it out to be already. The ones that I'm interested in is the fact that those two lines are parallel. If those two lines are parallel, I can go with co-interior angles. However, since parallel lines is not denoted on the diagram, I need to state it. So I said that AD is parallel to BC. Why? Because it's two pairs of opposite sides parallel in parallelogram. Okay? So now I can say that x plus 2x equals 180y. Co-interior angles with AD being parallel to BC. So that gives us 3x divided by 3 is going to give me an angle of 60. But have I answered the question? No. We know A is equal to C, which is equal to 60. Why? Because that is at x here. C will also be xy. C is x because two pairs of opposite angles equal in parallelogram. I think that's behind the calculator, but it's fine. At this point, you should know these things already. Okay. Then we know that angle B is equal to angle D, which is equal to 2 times 60, which is 120. Why? Because again, two pairs of opposite angles equal in parallelogram. And there we go. Okay. And the reason must be set there for you to get that mark allocated for that sum there. Number 3. In number 3 we are told that ABCD is a parallelogram with AD equals DE. Calculate the size of angle D and angle B. So as you can see here, we know those lines are parallel. So those angles are equal. With that I will be able to calculate A1. With that I will be able to calculate D, sum of triangles. You will agree with that? So what do I have to state first? I need to say that angle firstly AB is parallel to DC. Why? Two pairs of opposite sides parallel in parallelogram. Okay, then we see that E2 is equal to 62. So E2 is 62 degrees. Why? The alternate angles are equal with AB being parallel to DC. Then we know that A1 is 62. Why is A1 62? It's angles opposite equal sides. Then sum of triangles. So angle D is equal to 180 minus 62 minus 62. That is sum of triangles, and that is triangle ADE, which gives you 124, which is 56. Check if that's correct. 56. Then angle B is also 56. Why? Two pairs of opposite angles equal in parallelogram. Okay. A sum like this is easily 2, 4, 6, 7 marks minimum. Okay. 6 marks minimum. Question 5. Question 5. Question 5, we are told that AD is equal to AC equal to BC. And we are told that AB is parallel to DC. Prove that ABC is a parallelogram. Now we must prove it's a parallelogram. Prior to this, they told us it's a parallelogram. And when we prove something is a parallelogram, we prove one of 5 things. We have to prove the properties of a parallelogram exist in that quad for us to conclude it's a parallelogram. The 5 properties are, if we can prove that 2 pairs of opposite sides are equal, then the least it can be is a parallelogram. Or if we can prove that 2 pairs of opposite sides are parallel, parallelogram. If we can prove that 2 pairs of opposite angles are equal, it's a parallelogram. If we can prove that the diagonals bisect each other, it is a parallelogram. And one that is added to that is that if we can prove that 1 pair of opposite sides are equal and that same opposite side is parallel as well, then that is a parallelogram. So that one must be added in the contrary to the proof of a parallelogram. Okay? Remember, if they tell us a parallelogram, we know it's one of 4 things. If they ask us to prove it's a parallelogram, we can prove it one of 5 ways. For those 4 reasons, plus that one there as well. Okay? Learners often forget this one. Okay? So we write that in. Okay? So, there already we got that is parallel. So if we can prove that AD is parallel to BC, I've done the job. Not so. Right. But looking here, that was given. So we must prove that those lines are parallel. So what we say is we let angle A1 equal x. You'll see now why. If A1 is equal to x, which other angle will be equal to x? Not A1, sorry, A2 is x. Angle B is. Why is angle B x? Yes, angles opposite equal sides. Angles opposite equal sides. So if B is equal to x, which other angle is equal to x? C2, why? Alternate angles. With AB being parallel to DC. Now what? Angle D is equal to x, but it's not actually going to take me to what I was thinking of. Angle D is equal to xy, angles opposite equal sides. Some of these are necessary, but I will show you now. So what can we say? Here at least you can say opposite angles are equal. Not so. That's 1. But we also know that A1 is equal to angle C1. Also alternate angle. Not so. And we can say that A1 is equal to angle C1. So alternate angles here with. No, this can't be alternate. It's not alternate. Why is A1 equal to C1? Let's take you one step back. Why can't it be alternate? Lines are not parallel. Lines are not parallel. So I can't use the fact that it's alternate. But A1 is equal to C1. Why? Who can tell me? Isn't this the third angle in a triangle? So if A1, what would the size of A1 be in terms of x? 180 minus 2x is. What would C1 be? Also 180 minus 2x. Not so. So A1 is equal to C1, which is equal to 180 minus 2x. Why? It's the third angle in triangle. So you see here, so now we state the obvious. We say since angle D is equal to angle B, which is equal to x. That was proven. Okay? And angle DAB is equal to angle DCB, which is equal to 180 minus 2x plus x is 180 minus x. So this whole angle here is 180 minus x. Now I can say that angle D plus that angle equals 180. Can you see that? So therefore AD has to be parallel to BC1. Co-interior angles are supplementary. And then I can conclude, since two pairs of parallel lines, therefore it has to be a parallelogram. Or we can go from this straight into the fact that we now proven that that angle is equal to that angle, whilst this angle there is equal to that angle. We have proven that already. So we can say therefore ABCD is a palm or parallelogram. Why? Because you have two pairs of opposite angles equal. You can't use parallelogram here, no? So we're proving it's a parallelogram. So you say two pairs of opposite angles equal in a parallelogram. If you had gone with the co-interior, then you would have said two pairs of opposite sides parallel. Okay? So that's that. You look at question 7. Just take us off here. I just feel like there might have been an easier way, but since I've given you the memo to that, just check. There might have been something easier, but I'm not going to go into that now. The question is to calculate the angle of y. People, this is a rhombus. 6 properties come to mind. The one I'm interested in is the fact that that is going to be 90. Why is O1 90? The angles bisect perpendicular in the rhombus. There are 3 of those shapes where the diagonals of 3 quads where the diagonals are perpendicular. Which are the 3? Kite, rhombus, square. Those are the 3. Kite, rhombus, square. So O1 is equal to 90. Why? We are told that the diagonals are perpendicular in the rhombus. Okay. Now, this angle here is going to be y. Why is that angle going to be y? So how do we name that angle? CAB or OAB or BAO or BAC. One of those 4. Okay, it means all the same thing. So angle CAB is equal to y. Reason? Why is that y? Because the diagonal bisect the vertex angle. Okay. So how are we going to solve for y? Sum of triangles. So y plus 64 plus 90 equals 180. Y? Sum of triangles, and this triangle AOB. The angle y is equal to 180 minus 90 is 90, minus 64 is 20, 60. Okay. Next one, okay. Number 1. We are told that ABCD is a rectangle. 5 properties come to 1. 5 or 6. Okay, they want you to calculate x. But x is the same as a 1. Why is a 1x? Vertically opposite. Vertically opposite. Okay? So D2 would be 41. Angles opposite equal sides. But you have to first say that DO is equal to OC. Why is the length of DO equal to OC? Diagonals bisect each other equally. That should be your reasoning. Okay? Because those are the diagonals and they bisect each other equally, so that's the case. There are 2 shapes where that is the case. A square and a rectangle. Where the diagonals bisect each other equally. So you write here the diagonals bisect each other equally. It's probably behind the calculator again. So we're going to say that D2 is equal to 40 degrees. Why? As you said earlier, angles opposite equal sides. So now we can say that x plus 40 plus 40 equals 180. Why? Sum of triangles, and it's triangle DOC. That's 80, so x is equal to 100 degrees. Okay. We're going to stack somewhere, don't worry. Geometry will make you think, not so. So we're told that ABCD is a square. 7 properties come to mind. We are told that DB is 6. DB is 6. Let's calculate DC. How do you think you're going to do this? By using the theorem of Pythagoras. The theorem of Pythagoras is a right angle triangle. But we know that angle C is 90. Why is angle C 90? The vertex angle of square is perpendicular. Then we know that DC is called at x. Or just leave it without the x. Just leave our x out of the once, okay? So DC is equal to, what's DC equal to? BC. Why? Why is DC equal to BC? All sides equal in the square. Okay. So the theorem of Pythagoras, DC squared plus BC, which is the same as DC. Why do you think I'm keeping it like that? Because if you're going to write it BC squared instead of DC, then I have 2 unknowns in that equation. But as it stands here, we only have 1, so that we can solve the equation. So BC squared is equal to BC squared. No. DC squared plus BC squared is equal to 6 squared. Why? Because of Pythagoras, with angle C equals 90 degrees. So that's going to give you 2. BC squared is equal to 6 squared, which is 36. Divided by 2 both sides. So BC squared is equal to 18. The square root thereof. Normally when we introduce square root, plus minus. Not going to be plus minus here. Why? Because length is never negative. Why am I writing BC? Suppose I've written DC. No? So that is going to be DC is equal to, put in the calculator, you should get 3 root 2. Okay. Next year we'll speak about how the square root of 18 becomes 3 root 2. Okay. So that's that. Let's carry on with our lives. 11L. So in 11L we are told that ABC is a parallelogram. 4 properties come to mind. AE is equal to FC. Prove that. EBFD is a parallelogram. Okay, with the fact that 2 pairs of opposite sides are equal. Okay, but remember the original shape is also a parallelogram. So if we can prove that side is equal to that, and while that is equal to that, we've done the job. Not so? Right. So, in proving that DE is equal to FB, I'm going to go with congruency in those 2 triangles. Okay. I go with congruency. So we say in triangle AED and triangle BCF. Right. What can we say about those 2 triangles? Sorry? AE is equal to FC. Why? That was given to us. Another one. AD is equal to BC. Why? Sorry? 2 pairs of opposite sides equal in parallelogram. Or yes. One more. Angle A is equal to angle C. Why? 2 pairs of opposite angles equal in parallelogram. So is that enough to prove congruency? Yes. Which case of congruency is that? So therefore AED is congruent to triangle. So A is the same as C. You went to E, so it's the same as FB. We said side angle, side. And the original formation is not correct, no? Of the triangle BCF. Okay. So with this, we can conclude, therefore, DE is equal to FB. Not so? Why? Because triangle AED is congruent to triangle CFB. Alright. So now at this point, we have that being equal to that. Not so? So let's go with the other side. We know that AB is equal to, AB is equal to what? DC. Why? 2 pairs of opposite sides equal in parallelogram. 2 pairs of opposite sides are equal in the parallelogram. So that is equal to that. However, AE is equal to FC. Why is AE equal to FC? It was given. Not so. But remember, AB is made up of AE plus EB, not so. And DC is made up of BF plus FC. But if FC is the same as AE, then EB has to be equal to BF. Can you see the argument there? You will understand? Right? So therefore, EB is equal to DF by default. No? So, we have the fact that That is now also equal. So can we conclude a parallelogram? Yes. So we say therefore E, P, F, D is a parallelogram. Why? Because we have two pair of opposite sides equal. That normally goes at the bottom, no? The whole conclusion here goes to the bottom. Something like this with 8 marks. Okay? People, it's not going to be a waste to go learn these things, okay? You have to make sure that is in the exam, no? Sorry? What? Let's carry on with the notes. 10L. People, geometry is beautiful. Beauty, yes, it's beautiful. You listen, for those of you saying no, tell yourself every morning. Geometry, I love geometry. I love geometry. There will come a time that you start believing the lies you tell yourself. Okay, then you will see. But now, don't only tell yourselves that. You must practice it as well. Okay. This is one thing. Once you get it, then you have it. Because it's going to be a big section in your paper 2 grade 12. It's not Mickey Mouse. You think I'm wasting my time here? No. I'm putting emphasis on this geometry because of the importance of it. Okay. People, we are told that a BCD, this angle here, BCD is equal to 60 degrees. BCD. BCD. So the other angle is 60. Then we are told that AC bisect angle BCD, which means to say C1 is 30 and C2 is 30. Prove that ABCD is a rhombus. So if this is a rhombus, what do we need to prove? We need to prove that the diagonal bisect the vertex angle. There are three shapes where that is evident. The diagonal bisect the vertex angle, which is a parallelogram. No. Oh, you say it's not a parallelogram. Okay, nice. It's a square, yes, but that is 45. But this one is now not 45, so there can't be a square. A rhombus, yes, and that's what we're going to try and prove. And one more. A kite. However, a kite, you have two pairs of adjacent sides equal. Is opposite sides equal in a kite? Is opposite sides parallel in a kite? No. So this can't be a kite. You will agree with it. So if I can prove that the diagonal is bisecting its vertex angles, then the job is done. So I must prove, in other words, that A1 is also equal to A2. Alright. So where do we start from here? We say firstly that is given to us. So now we can say that C1 is equal to C2, which is equal to 30 degrees. Why? Not given. Yeah, you're right, given. Given that AC bisect BCD. Okay. Then we know that A2 is 30. Not so. A1 is also 30. Both alternate angles but different parallel lines. Okay? So we're firstly going to say that A2 is 30. Why is A2 30 degrees? Because of alternate angles. Alternate angles with BC being parallel to AD. Then angle A1 is equal to 30 degrees. Why? Why is A1 30? same story. Alternate angles with AB being parallel to DC. So what do you notice now? No? Don't you notice that AC is bisecting this angle here as well? Not so? So we say, now we state the obvious. Since diagonal AC bisect DAB, therefore A, B, C, D is a rhombus. Why? Because the diagonal bisect the vertex. And also the fact that it's from a parallelogram. Okay, this is a parallelogram with those opposite sides being parallel as well. Okay. I think it should have been fair for us rather to open up with the fact that ABCD is a parallelogram as well. Okay. Next, 10L. Here we are told that a DO is equal to OF equals a GO equals OE. Two shapes this could be. It could be one of two shapes. Just reading that top part here. With angle D, just this first part here. Two shapes this could be. Can either be a square or a rectangle. Yes, well done. Could be a rectangle. There's only two shapes where your diagonals bisect each other equally. It's a rectangle and a square. Then we are told that DOE is 90 degrees. So remember now, it's a rectangle or a square. Right, because of the 90. No, because of the diagonals. No? Then, with that being 90, this could be one of three shapes, where the diagonals are 90 degrees or perpendicular. What are the three shapes? A square, kite, rhombus. So what do you notice? Squares in both. So it has to be a square. Did you guys see that? But this is just doing your head, no? You don't write it. Right, so let's see what they say here. Prove that all sides are equal. Prove that all sides are equal. So what you can do is you can prove congruency. I would go with congruency. I would prove congruency in this triangle here and that triangle. Okay? Then you prove congruency in that triangle there and that triangle there. However, and you prove congruency here and there. That means to say that all the angles, all the triangles will be. Not so? So if all the triangles are equal, in turn, all the sides will be equal as well. Okay, I'm not going to prove it now. It will take me a good couple of minutes to do that, to write it out. Then in number 2, we are told that if D1 is equal to E2, which is equal to X, prove that angle E is 90. So if that is X, that is X. Remember, this is now a all sides are equal, not so? So what can I say now? They are congruent triangles. So that's why all those angles are equal. Okay? So x plus 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 x adds up to 360. The interior angles of a quad. So it's 2, 4, 6, 8, 8x is equal to 360. Interior angles of quad 360 divided by by 8 is going to give you 45 degrees. So every angle is 45. So if that is 45, 45, I'm going to say 45 plus 45 plus DOE. Oh, wait. They want angle E. So that is angle E here. No? So angle E, which is basically DEF, is equal to 2x, which is 2 times 45, which is 90 degrees. Okay, and there we have, they could have asked you then to prove it's a kite, not a kite, a square, and I'm sure you know what to do from there. People, this is what I want to get out of. Worksheet 10M. Now this is the midpoint theorem that comes into play. Now the midpoint theorem, I'm going to send you a link to a video where they prove we have proven the midpoint theorem already. Okay? We don't have time, we got like 10 minutes left of the speed it, so I'm just going to spend some time on this here. The midpoint theorem, I want you guys to write down as follows. The application of the proof of the theorem is not examinable, so we won't ask you in the exam to prove the theorem. Okay? Or should I? You want me to ask you? It's nice 6 marks. Okay. So if this is ABC, you need to write this down. A, B, C, D, E. If you connect, if you take, wait. Let's go A, B, C, like that. Okay. You're looking. If you take the midpoint of AB, let's call that E. And the midpoint of AC, let's call that D. Right? We took the midpoint of AE and the midpoint of BC. And we're connecting it to the midpoint of AD and the midpoint of BC. I draw this line here. If that is the case, then we can conclude that DE, this line here, is parallel to BC. Okay? Make sense? Right? And the line BC is double DE. Okay? Or double ED. So if this line here, so firstly that will be parallel, and this here, if that is x, this will be 2x, double. So if that line was 50, then this is 100. If this was 80, then this is 160. If this is 50, then this is 25. If this is 80, that is 40. And if we use this theorem, we just say it's the midpoint theorem. We use any of these, we say it's the midpoint theorem. Okay, just say midpoint. Alright? You guys know what is converse? Not the shoes. Converse is, in geometry, we got the theorem. When we say the converse of the theorem, then it's basically the reverse of that theorem. Okay, the converse is the reverse. Okay. So the second diagram I want you guys to draw quickly. We got the triangle PQ. I could have used ABC again, but I don't want to use the same letters, otherwise you get confused. Okay. So what I do is I take the midpoint of PQ, or I could have taken the midpoint of RP. The same thing, no? I take the midpoint of PQ and I draw a line parallel to QR. So that is what is given here. PQR is, and we call this thing. Okay, so what we got? We got PS, the midpoint, or PS is equal to SQ, and we got that ST is parallel to QR. If that is the case, then we can conclude. Then, what can we say about this? PT is equal to QR. What else can we say? We can say that QR is equal to twice ST. Now people, if your diagram looks like this, the reason is midpoint theorem. If your diagram is looking like that one here, then we say it's the converse, which is the reverse of the midpoint theorem. Yes, Michael? Yo, I thought you were going to ask me something about the diagrams. Go to the toilet. Now you're going to miss this exciting work. Okay? Alright, you guys understand? So if you are given two midpoints as joining, midpoint theorem, as you can see here. If you're going to use this diagram, the second diagram, with one pair of equilates and a parallel line here, parallel to the third side, then we're going to use the converse of the midpoint. Okay, you guys understand? Write that nice and big. We're going to use this extensively now. Okay. So here we are told in theorem now. Theorem. We are told that BC is 20. BC is 20. Then AD is equal to BD. AE is equal to EC. Then we are told that if C is parallel to AB and if C is 6, the question says, and then we are also told that DEF is a straight line. Calculate the length of ED. So what is ED? It's easy to say it's 10. You all can see the 10. Let's look here. Which diagram is this? The first one or the second one? Not the second one. Nice. The first one. The midpoint theorem. Not so? So you all can see that. But the thing is, we can't just go in and say it's a midpoint theorem. We state it first. We say since. Now we do the argument for the midpoint theorem. Since AD, before I actually put the C, we have to state it. Okay. So since AD is equal to DP, where is that coming from? That was given to us. And AE is equal to ECY, given. So there is my argument for the midpoint theorem. Can you see that, people? Therefore, DE is going to be a half of 20. Why? Because it is the midpoint theorem. You guys understand? Which makes it 10. Or I could have just said D is 10. I don't have to say this part here, but of course the midpoint theorem comes into it. Alright, so I'm going to put 10 here because I've added that to the diagram afterwards. So that is number 1. Number 2. Number 2 says the length of AB. What is the length of AB? is going to be, if we are told that FC is 6. So BD is 6. Not so? If that was a parallelogram, then I could have said that is 6. So, can you see that, people? I can say that is 6, 6 and it's going to give me 12. I know the answer is 12. But I need to first set up the argument why I can say that this is 6. Because they didn't tell us that and that is equal. If they did, then I could have just said BD 6 given, and then you can conclude that that's also 6 because that was given equal and then 12 in total. But that is not the case. So firstly I must prove that B if C no, D if C B is a parallelogram. Once I do that, I can say that opposite sides are equal. Can you see that, people? But they did not tell us the parallelogram, so I can't just assume it's a parallelogram. I must lay down my case why it's a parallelogram. So what do we say? For parallelograms, one of 5 things I'm going to prove. I'm going to use the 2 pairs of opposite sides of parallel. So we know that D, E, F, this line here, is in fact parallel to BC. Why is that the case? Who can tell me? Why is that parallel to this? Yes! That's what we had just gave you now earlier on. It's the midpoint theorem. Not so. Midpoint theorem. So that is now parallel. So since that is parallel and BD is parallel to CF, since that is parallel there and that is parallel, can you see that, people? Therefore DFCB is a parallelogram. Why? Because it has 2 pairs of opposite sides parallel. 2 pairs of opposite sides parallel. So this is a parallelogram now. So because this is a parallelogram, I can now say that BD is equal to FC, which is equal to 6 millimeters. Why? Why is that 6 millimeters? Because 2 pairs of opposite sides equal in parallelogram. Why can I use parallelogram? Because I have proven it now. I've proven it is a parallelogram. So AD is equal to BD, which is equal to 6 millimeters. Why is that also 6 millimeters there? Where is this coming from? It was given to us. So therefore, AB is equal to 12 millimeters. People, there's 3, 4, 5, 6 marks, 7 marks you can get for the sum. 3 and 4 in the second one. Okay. Right, let's look for another one. I did number 2 because this diagram looks very familiar in terms of examinations. Okay, this is how it gets asked. Okay, put your answers. So I'm doing it so that you guys can be exposed, and when you go through the work again, you guys must not watch the videos. When you go through the work again, it will remind us of something we did. Okay. So we are told that BE is equal to ED. So BE is equal to ED, which is equal to CD. So all these lengths are equal. Okay? What do you see here, people? Okay, and then we tell that BF is equal to MA. What do you see here? The midpoint theorem again. Can you see that? So we know that FC is parallel to AD. Now FE, what is this? if E is parallel. We also know that that is double that. Or half basically. Can you see that, people? So that should jump out immediately at you. Okay, then we tell that KD is 15. KD is 15. And AKD is a straight line. AKD is a straight line. Okay? Calculate FE. People, they want, what is FE? We can all see FE is what? 30. Not so? However, I must use the midpoint theorem first. I must first state the midpoint theorem. Can you see that, people? So where do we go from here? For the midpoint theorem, what do I need? I need the two midpoints connecting, or I need one midpoint and a pair of parallel lines, yes. One of the two. Now, you see we got that being equal. Is that even equal to that here? No. Can I prove it? No. However, it's going to be easier for me to go with the fact that that line can be parallel to that line. Why? Because of the initial diagram. There's a midpoint theorem that can be applied there already, which is resulting in those lines being parallel anyway. Can you see that, people? So I first need to go through that notion there before I come out to be 30 on that line. So let's do that quickly. And I'm saying a lot at once, no? Yes. But because we started off slowly, man, that was a mistake. So FE, so firstly we are given that AF is equal to FB. And we are given that BE is equal to ED. That was given. Okay? So therefore, FE is parallel to AKD. Why? Because of the midpoint theorem. That is parallel. Alright. Now, this was in triangle. We just put here in triangle ABD. So let's work in the other triangle. In triangle CFE. CFE. What can we say? That CD is equal to DE. Why? That was given to us. Then we know that KD is parallel to FE. Where did we get that now from? Proven above. Can you see this is now parallel to that? Now proven. So does that line up with the converse of the midpoint theorem? Yes. We have the midpoint of one segment of the line, and the third side being parallel to the line drawn there. Can you see that, people? So therefore, FE is equal to double DK. Okay, okay? Why? Because it's the converse of the midpoint. Converse of the midpoint theorem. So which makes that 2 times 15, which is 30 millimeters. There goes 30. Okay. So what I'm going to do is I'm going to take this off because I want to keep the diagram in focus. Okay. 2.2. They want you to calculate AD. Now, AD, can you see this diagram? That what is AD? It's double 30. Not so? Okay? So do I have to again say that AF is equal to FB and B is equal to ED? No, because I've seen it already. We already laid out our argument for the midpoint theorem. So simply we just say that AD is equal to 2 times FE. Why? Because of the midpoint theorem. Okay? So So it's going to be 2 times 30, which is 60. So this whole length is 60. 2.3. They want you to calculate Ka. Ka is that length there. Not so, people. So Ka is equal to 60 minus 15, which is 45 millimeters. Okay. Yes, these nice ones here, didn't even have a chance to do. Okay. So hopefully, with the next year's group, we'll move a bit faster and then I'll wrap up this with it. Okay. People, that brings us to the end of geometry. Tomorrow we're carrying on with trigonometry. People, enjoy the rest of your day. Good morning, class.